Hi guys, today we're going to cover section 3.2 linear equations in two variables. So things to know, the definition, graphing x and y intercepts, and the horizontal and vertical lines. Now, when we talked about this in class, we called the equation of two variables an upgrade because we talked about equations in one variable. So if you remember, linear equations in one variable takes the form of ax plus b equal c, right? Where a is not equal to 0, okay? And then, so when we upgrade it to two variables, all we're going to do here is we're going to attach a y with a b instead. Okay, so instead of ax plus b, now we have ax plus by equal to c. And again, a and b cannot equal to 0 at same time. Okay, so some basic definition. Excuse me. So the two variables is very similar to one variable. So that means that a lot of things that we did with the one variable, we're going to do the same thing, right? Or in the two variable. So let's go ahead and try some of these problems. So 3x plus 2y equal 11, right? We're given a point 3,1, and we want to check to see if 3,1 is a solution. So if you remember, right, how do we check to see if a point is a solution? Well, we plug it in to see if it works. So I'm going to just plug it in. So x equal to 3, and 1 equal to y, and I'm going to check to see if this is indeed equal to 11, right? Notice I put a question mark there because I'm not sure if it's equal or not, so I put a question mark. So I'm going to work at my left-hand side, simplify my left-hand side. I got 9 plus 2, which is 11, and 11 equal to 11. So the point 3,1 is indeed a equation. Excuse me, a solution. Okay. Now again, the second problem, right? We got 4x minus 5y equal to 2, and we want to check if 2 is the answer to the equation. So again, plug it in. So 4 times 2 minus 5 times 2 equal to 2. Hopefully. Again, question mark because I'm not sure that's true or not. So 8 minus 10. Now 8 minus 10 is definitely not 2 because 8 minus 10 is negative 2. So negative 2 is not equal to 2. So the answer is no. So 2 is not a solution. Okay, because when you plug it in, it doesn't work. All right. Okay, so again, right, this is something we did with the one variable equations. We just want to double check to see if things work. So we plug it in, evaluate, and see if it works or not. All right, let's go to the next part. Now, next part we're gonna do a little bit of graphing. Now, as you can see on the notes, in order to graph, right, first step, we're supposed to make an x and y input-output table. And the bonus here is we're going to consider x and y intercepts. Okay, second, plot the points. And the third is our favorite, we connect the dots. All right, so let's go ahead and take the first problem, for example. You have 2x plus 3y equal 12. Okay. Now, unfortunately, I'm not able to pull up a grid, so you're just going to have to try to follow accordingly. But first thing first, let's make a table. All right, so your x and y table or input-output table. And in this case, right, what I always tell students is this format right here, the 2x plus 3y equal to 12, or the ax plus by equals c in general, this is called the standard form. Or general form, depending on the textbook. Okay, so anytime if I see ax plus by equal to c, my first go-to are going to be I'm going to let x equal to 0 and figure out what y is. And my second point is I'm going to let y equal to 0 and figure out x. Reason being, we like to plug in zeros because 0 makes things disappear. And in this case, if you plug in 0 for either x or y, that entire term cancels out because it becomes 0. Okay? Because anything times 0 is 0. So that's the reason why we'll pick those. But however, it doesn't hurt to pick a couple more checkpoints. Right? Reason being, so fast forward, if you're done with all the points and when you connect them, they all should be on the same line. So when you pick those 3-4 points, right, the first 2 points will get you the line, but the other 2, the checkpoints, will make sure that all the points are on the same line. So which means if you have a point that's offline, something is not right. Okay, so that's the reason why we usually pick 3 to 4 points. But let's go ahead and get started. So I'm gonna first let x equals 0, and we're gonna solve for y. Okay, so you x equals 0, that means 2 times 0 plus 3y equal 12. 2 times 0 is 0, we like that. So you get a positive 3y, or just 3y equal to 12. And divide by 3, y equal 4. So there it is. Okay. Same thing again, but this time we're gonna let y equal to 0. And we're gonna solve for x. So 2x plus 3 times 0 equal 12. Again, 3 times 0 is 0. So 2x equal 12 and x equal 6 after you divide by 2 on both sides. Okay, so those 2 points typically are pretty easy to find. Now, just be careful. In this case, we actually got pretty decent answers, right? 4 and 6, but it is not uncommon to get answers that are not as nice. You might get a decimal, you might get a fraction, okay, and that's where the checkpoint comes in. Sometimes checkpoints are the points that's gonna actually have nice answers. Okay, so you just got to keep that in mind. Picking zeros for x and y is not foolproof, but at least usually, it's a good start. Okay, let's go and pick some points. Now, I think in class I had everybody, just kind of trying to figure out to see if they can, come up with some checkpoints. Some people come up with 3 and 2. 2 times 3 plus 3 times 2, that's 6 plus 6, which is 12, right? So that's okay. And some people also came up with, what else? I think we only did 3, 2, but you could definitely come up with more points. I mean, if you want to, come up with, you can use negative or positive numbers for x and y, but I think for our sake, we only picked 1, and so we'll see if that works. Now, if you put on your grid, right, 0, 4 will be up here. 6, 0 will be 1, 2, 3, 4, 5, 6 to the right. And 3, 2 will be 3 to the right and 2 up. And now, I'm doing this freehand, so it doesn't look very accurate. But once you put on the grid and use a ruler, you can see that all the points lay on the same line. Okay? All right, so let's go ahead and try another one. So this time we're going to do negative x plus 4y equal to 5. And again, let's go use our table. Okay, so again, use 0 and 0. Now, this time I gave class a hint. Because if you try to plug in 0 for x, so you plug in 0 for x, you get negative 0 plus 4y equal to 5, which means this is 4y equal to 5. And you get, divide by 4 on both sides, you get y equal 5/4 or 1.25. When it comes to graphing, we really want to try to avoid fractions and decimals because those are hard to graph. We want to try to stay with answers that are integers. Okay, But this doesn't make the point any less valid. It's just that it's a hard point to graph. Okay, let's go and keep going. Now this time let y equal to 0 and solve for x. So which means you got negative x plus 4 times 0 equal to 5. 4 times 0 cancels out. You get negative x equal 5, so x equal negative 5. Okay. So now let's figure out a couple of checkpoints. Okay, hopefully we can pick out some checkpoints that are integers, right? The x and y are integers. So the hint I gave class is, if you look ahead, right? If you're trying to solve for y, notice we had to divide it by 4, right? So why don't we pick? So the hint I gave here is choose y value first. Okay, so instead of trying to pick x, which is like what we usually do, let's pick y values first, and we're going to solve for x. So in the class we picked 1, and we also picked 2. Okay, notice if y equal to 1, you have negative x plus 4 times 1 equal to 5. That's negative x plus 4 equal to 5. Minus 4 on both sides, you get negative x equal to 1, which means x equal negative 1. Repeat the process again, now this time with 2. Negative x plus 4 times 2 equal to 5. Negative x plus 8 equal to 5. Negative x minus 8 on both sides. You get negative x equal to negative 3. And x equal positive 3. Okay, now, so from here, if you graph it, you get 1, 2, 3, 4, 5, negative 5, 0. You get negative 1 and 1. You get 3, 2. Connect the dots. Again, freehand, so not as accurate, but if you put on the grid, all 3 points should lay on the line. And notice the 0, 1.25, I mean, that's right there. Again, we don't like to have deal with decimals or fractions when it comes to graphing, so we try to stay with the whole numbers. Okay. All right, the next page, right? The next page we're saying, hey, you have y equal 2/3 x minus 4. And in this case, again, we're going to pick an x and y table. But the hint is, make sure you pick nice x values. Okay? So the question I asked class is, well, what do I mean by nice x values? What you need to think about is, what's going on with the variable x? Notice the variable x is being multiplied by 2/3. Okay? And again, right? Anytime you multiply by 2/3, that means potentially your answer could be ugly because you have a fraction. So what you need to think about is, how do you cancel fraction? So how do you cancel fraction? Again, we did this when we were solving equations in test 1, right? Notice 2/3 is the denominator of 3, which means I need numbers that are multiples of 3, which means I should be picking 0, I should be picking 3, or 6, or negative 3 is okay, as long as it's a multiple of 3. So let's go ahead and try this out. So first, let x equal 0. Y equal 2/3 times 0 minus 4. 2/3 times 0 is 0, so y equal negative 4. Next one, we're going to let x equal to 3. So y equal 2/3 times 3 minus 4. Right, remember 2/3 times 3 is the same as 2/3 times 3 over 1. And again, right, when we multiply by fractions, we reduce before we multiply. 3 and 3 cancels out. you're left with 2 over 1, or just 2, minus 4, which is negative 2. Keep going. Let x equal to 6, y equal 2/3 times 6 over 1, or just 6, minus 4. 3 goes into 3 one time, goes into 6 twice. 2 times 2 is 4, minus 4 is 0. Okay, you can basically, once you got the pattern down, the answer should all turn out pretty nice. Let x equal negative 3. So y equal 2/3 times negative 3 over 1, minus 4. 3 goes into 3 one time, goes into negative 3 negative 1 time. So 2 times negative 1 is negative 2, and we have a minus 4, which gives us a minus 6. So if you graph it, 0, negative 4, 0, 1, 2, 3, 4, 1, 2, 3, negative 2, 4, 5, 6, 0, and the negative 3, negative 6 will be somewhere right here. Again, drawing not to scale, because I was being freehand. So, okay, so there's that for general graphing. Now the last two we want to talk about is the vertical line and horizontal line. Notice I gave you the formula, right? Formula for horizontal line is always y equals some constant. So y equal to 5 means I should have a horizontal line, right? But be very careful. The biggest mistake is most people, when they see y equal to 5, they think it's a vertical line because y-axis is vertical. Okay, so be careful. Y-axis is vertical, but y equal to 5 is not vertical. Okay, reason being, right? If I know y equal to 5, and notice there's no x variables in the equation, so which means y is always 5. And it doesn't matter what x value you pick because there's no variable in the equation. The x value does not affect it. It doesn't matter. So you could pick 0, 1, 2, 3 if you want. Plot those points. 0, 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. 2, 1, 2, 3, 4, 5. And notice, see all the points lined up in a row horizontally. Okay, so be very careful. When you have a y equal to 5, it is actually a horizontal line, not just because y-axis is vertical. Okay, same reasoning. X equals 3 is a vertical line because when you make a table, right? X is always 3. And it doesn't matter what value you pick for y, it's not going to change the equation. So you could do 0, 1, 2. And if you do that, you get 3, 0, 3, 1, and 3, 2. So be very careful, right? Y equal to 5 is a horizontal line, and the x equal to 3 is a vertical line. Okay? All right, that's all we got for 3.2. Any questions, let me know. Have a good day, guys.